Good morning, students. Present topic is interpolation, particularly interpolation with equal intervals. First, we will see what is meant by interpolation. Suppose we have the following values of y equal to f of x for a set of values of x values x naught, x1, x2, x3, and so on, xn, which are equally spaced, and corresponding y values y naught, y1, y2, y3, and so on, yn. Then the process of finding the values of y corresponding to any value of x equal to xi between x naught and xn is called interpolation. Thus, interpolation is the technique of estimating the values of a function for any intermediate values of the independent variable. The study of interpolation is based on the concept of differences of a function, which is discussed below. Interpolation with equal intervals. Suppose that the function y equal to f of x is tabulated for the equally spaced x values, corresponding x values, equally spaced x values, and the corresponding y values. To determine the value of f of x or f dash of x for some intermediate values of x, the following types of differences are useful. Even not only for f of x, for differentiation derivatives also, following types of differences are useful. First one, forward differences. The difference y1 minus y0, y2 minus y1, y3 minus y2, yn minus yn minus 1, when denoted by delta y0, delta y1, delta y2, and so on, delta yn minus 1, respectively, are called the first order forward differences, where delta is the forward difference operator. Similarly, in general, the first order forward differences are defined by delta yr is equal to yr plus 1 minus yr. Similarly, you can define second order, third order, and fourth order. The general formulae for those are delta square yr is equal to delta yr plus 1 minus delta yr, and delta cube yr is equal to delta square yr plus 1 minus delta square yr. Delta power 4 yr is equal to delta cube yr plus 1 minus delta cube yr. Means second order differences will come from first order differences, third order differences will come from second order differences, and fourth order differences will come from third order differences. These differences are systematically represented in the following table, which is called as forward difference table. This I am showing in a tabular form. Let the given data be this data, and then the forward difference table, how it will be means like this will be there: x column, y column, first order differences, second order differences, third order differences, fourth order differences. It will go continuously. Depends on how many number of values of x and y are there. In the above difference table, x is called argument and y is the function of the entire entry. Okay, next. First entry is called the leading term, and delta y0, delta square y0, delta cube y0 are called the forward differences. Next, similarly, backward differences, the difference is same, notation will be different, that's all. Represented by del nebula, okay, in the same format. Backward differences, and the table for backward differences, denotation is different. Everything difference is also same, but the denotation is different. Then Newton's forward interpolation formula. By using forward differences, let the function y is equal to f of x takes the values y0, y1, y2, and so on, yn, corresponding to the values of x0, x1, x2, and so on, xn of x. Then to evaluate y is equal to f of x at any point of x, which is nearer to the beginning values of x, then the formula is given below. When we have to find out the value of y at an x value, which is beginning to the given x values, then we have to use Newton's forward interpolation formula. And the formula is this one, where p is equal to x minus x naught by h, and h is xn minus xn minus 1, difference between any two successive values of x. This formula is Newton's forward interpolation formula. Similarly, Newton's backward interpolation formula, when we will go for this Newton's backward interpolation formula means, whenever you have to find out y at x value, where x is at the near to the ending values of x, last values of x, the formula is this one. Simply difference is p plus 1 instead of minus plus, and forward differences here backward differences, but here p is x minus xn by h, and h is same. This is called Newton's backward interpolation formula. Now we will see problems. Fit the cubic polynomial which takes the following values and hence evaluate f of 4. Here it is asked to fit a cubic polynomial and it is asked to find f of 4. Even though that f of 4 is near to the ending values, it is asked to fit the polynomial first. We will follow the forward formula only. We know that the Newton's forward interpolation formula. Suppose the same problem, if it is asked to evaluate f of 4 directly, then we can use Newton's backward interpolation formula. We know that the Newton's forward interpolation formula and what is P and what is H we listed here. Then we need delta square y, delta y naught, delta square y naught, delta cube y naught, and so on. And that we will see with the table. Forward differences table, x column, x values denoted with x naught, x1, x2, x3, and y column corresponding y values denoted with y naught, y1, y2, y3. And the first order differences delta y, simple down value minus upper value, delta y naught, 2 minus 1 is 1, then delta y1, y2 minus y1, delta y2, y3 minus y2, simple down minus upper value. Then second order differences will be calculated from first order differences, down minus upper value. Similarly, down minus upper value. Next, third order differences, down minus upper value, 10 minus of minus 2 will become 12. Now for first forward differences, we need these values only. We don't want any other values. We will list out that values. From the above table, you have y naught, delta square y naught, delta cube y naught. And P equal to x minus x naught by h. For polynomial, x equal to x only. If we want to find any particular value, that x value will become that given point. So P equal to x only. You substitute all these values in equation 1. We will get, and if you simplify, you will get the polynomial as required cubic polynomial as 2x cube minus 7x square plus 6x plus 1. And it is asked to find f of 4 also. F of 4 is equal to, substitute 4 here, you will get 41. Okay, next problem. Using Newton's forward formula, find the value of f of 1.6 from the following data. At which points it is given 1, 1.4, 1.8, 2.2 it is given, and it is asked to find 1.6. But the formula is mentioned, Newton's forward formula. We know that the Newton's forward interpolation formula is listed the formula. Take it as equation 1, list out what is P and what is H. Then calculate these differences using the difference table. X values, y values, first order differences, second order differences, and third order differences. List out the upper diagonal values only required for the forward interpolation formula and substitute in the formula by calculating P. Why it is x substituted at 1.6 means at x equal to 1.6 it is asked to find f of 1.6. That's why x equal to 1.6. Substitute all these values in equation 1, and if you simplify, you will get f of 1.6 as 5.4394. Okay, next. Find the interpolating polynomial f of x which is satisfying the values f of 0 equal to 0, f of 2 equal to 4, f of 4 is equal to 56, f of 6 equal to 204, f of 8, f of 10 is given. Means the function value is given at 0, 2, 4, 6, 8, 10. What it is asked to find? Polynomial. Then it is asked to find f of 3, f of 5, and f of 7. Polynomial means generally we will use forward interpolation formula only. If you list out the given data in a tabular form, x column, y column, and the Newton's backward, we are using Newton's backward. Polynomial means you can use either forward or backward. Once you did with the forward, now here I am doing with backward interpolation formula. Then we will construct the backward differences table. X column, y column, del y, del square y, del cube y. Please remember, when you are using backward interpolation formula, down diagonal values required. When you are using forward interpolation formula, upper diagonal values are required. List out the down diagonal values and calculate P. Here polynomial means x equal to x only. X by 2 minus 5 is there. Now equation 1 implies substitute here. See, p value x by 2 minus 5 came. So it is little bit difficult to simplify. Suppose if you take forward interpolation formula, x naught will become 0. So only x by 2 will come, minus 5 it won't come. Otherwise minus 5 simplification will be little bit difficult. So f of x equal to x cube minus 2x. Whichever the formula you use, you will get the polynomial as same. No change in it. So then it is asked to find f of 3, f of 5 and f of 7. Okay. Next problem. The area capital A of a circle of diameter d is given for the following values. Calculate the area of a circle of diameter 105. So for what diameters the area is given at 80, 85, 90, 95, 100 is given, and it is asked to find the area with the diameter 105. 105 is nearer to the ending values, so you'll use backward interpolation formula. Assume d is equal to x and a is equal to y. Why? Because means we studied the formula in terms of x and y only. Okay, now we are going to use backward interpolation formula, so we'll construct backward differences table. D equal to x column, A equal to y column, del y, del square y, del cube y, del power 4y. Now backward means only down values are required. I am marking here xn, yn, del square yn, del cube yn, del power 4yn. Okay, then list out the values and substitute in the formula. You will get y of 1.5 as 8,666. So area of a triangle, area of a circle with the diameter 105 is 8,666 square units. So this is the answer. Like this, you can do all the problems. In the next lecture video, we'll see the interpolation with unequal intervals. Okay. Thank you.